This is section 4.2, precipitation reactions. Precipitation reactions are reactions where two solutions are mixed together and they'll make a solid. The solid has a fancy name. It's called a precipitate, or PPT. A precipitate is a solid that forms when an insoluble substance, one that can't dissolve, forms. Precipitation reactions are many times called exchange or metathesis reactions. Exchange or metathesis reactions are also known as double replacement reactions, where you have a cation and an anion reacting with a different cation and anion, and the cations exchange, where A will now hang together with Y, and X will now hang together with B. The cations will always go first. The anions will always go second. And one of these two, or maybe both, will form a solid or a precipitate. Let's do some examples of these, and then we'll do examples of how to write them three different ways. Way number one is called a molecular equation. The second way is to write what's called the complete Ionic equation. And the third way is called the net Ionic equation. We'll learn how to write all three equations, and we'll use several examples for each one. First, let's take the reaction lead nitrate, aqueous. Of course, it's soluble because it has nitrate in it, and these are all dissolved in water. Reacts with potassium iodide, aqueous. When this happens, the lead and the potassium swap places in the metathesis or replacement reaction, forming lead, iodine. Lead is a positive 2 cation. As you can see here, there are two nitrates. I forgot to put this 2 in here to start with. And nitrate's -1. Lead is positive 2. Iodine, from the periodic table when it forms with a metal, is a -1 ion. And so the formula will be PbI2, a -1 ion and a positive 2 ion coming together. The potassium will then form with nitrate, forming KNO3. Using your solubility rules, you can now go through and identify whether each of these has formed a solid or a precipitate. Your solubility rules indicate that all iodides are soluble except for silver, mercury, and lead. Lead iodide would not be soluble, and so this would be a solid. Potassium nitrate, you can see that it's soluble from two standpoints. All nitrates are soluble, and second of all are soluble from the alkali metal cations, and potassium is a member of that class. This would be aqueous. This is called the complete molecular equation. We now go through and balance this reaction, needing a 2 here for Ki and a 2 here for KNO3. Next, we'll take this reaction and we'll write what's called the complete Ionic equation. When you write the complete Ionic equation, you take everything that is aqueous, and a strong electrolyte, and separate it into its ions. Lead nitrate is aqueous and a cation and an anion, a strong soluble salt. Therefore, this would separate into Pb, positive 2 ions, and 2 NO3 minus ions. The potassium iodide would separate into 2 K plus ions and 2 I minus ions. How did I know to separate this? Well, I knew that Ki was aqueous and that all potassium salts are soluble and all iodides are soluble except for silver, mercury, and lead. So it was soluble for two ways. I could put AQ below each one of these items if I wanted to. Over here on this side, this is a solid, so I do not split it up, so I keep it together as PbI2. And this one I'll separate once again because it's aqueous and doubly soluble. Both potassium and nitrate are soluble. It only takes one of them, but since both of them there, it's like super soluble. NO3 with a -1 charge. This is called the complete the complete ionic equation. I already wrote the complete molecular equation up above. This is the complete ionic equation. Now you'll notice on both sides of the reaction there are some things that are exactly the same. The two K pluses right here are exactly the same. They have not changed from one side of the reaction to the other. You'll also notice the two nitrates are exactly the same from one side of the reaction to the other. Since they do not change and they simply watch the reaction happen, these boxed in items are called spectator ions. They simply observe the reaction occur. Take the other items that do react and rewrite them as Pb positive 2, 2I minus forms PbI2, and you now have what is called the net ionic equation. The net ionic equation only involves species that actually had something happen to them in the reaction. The ones that only went and formed the solid. The ones that were aqueous before and then came together and were no longer aqueous but formed the solid precipitate. Let's do one more example of a net ionic equation, and then you'll have a number of these to write for homework problems as well. First, the steps. First of all, write and balance the molecular equation. Step number 2, rewrite the equation as ions. Split things into ions that are soluble ionic compounds, strong acids, and strong bases. In other words, anything that is a strong electrolyte split into an ion. Keep things together that form solids. Leave together. This will give you the complete ionic equation. Then in step 3, cancel anything that is the same on both sides. These are called spectator ions. Rewrite the ions that remain that form the solid, and you have your net ionic equation. So, one more example of this. Let's take a look at a reaction of calcium chloride, aqueous solution. And let's look at silver nitrate, aqueous solution. Once again, it is a metathesis or a swap the cations reaction. Take the calcium and the silver and switch them. Calcium will then go together with the nitrate. Calcium, looking on your periodic table, is a +2 ion. So you'll need a 2 down here since nitrate's -1. Silver will go together with the chlorine and form silver chloride. Silver, remember, is one of those that does not need a Roman numeral because it's always +1. And then chlorine, of course, is in this group. It's -1 when with a metal. So silver chloride is correct. And now let's go through and assign whether these are solid or aqueous on this side. Nitrates. Nitrates are always soluble, so we'll put aqueous for calcium nitrate. Iodides are always soluble except for silver, mercury, and lead. So the silver iodide will form a solid. The calcium nitrate, of course, will be aqueous. We've now accomplished number 1, except we haven't balanced the equation. I'll need a 2 here and a 2 here to balance the silvers and the nitrates and the chlorines. Next, write the soluble ionic compounds, aqueous items, as ions. So split the calcium chloride because it's a strong electrolyte. Don't forget to bring the 2 up here to indicate there are 2 of the -1s. 2 silvers, 2 of the nitrates. Notice how the 2 distributed into each one of those species. Calcium nitrate, once again soluble, and 2 of the NO3s. Notice how the 2 came out front here because it was 2 of those nitrate ions. And then the silver chloride remains together because that's a solid and a precipitate, and never split a solid or a pure liquid or a gas. Items that would cancel, calciums will. Those will be spectators. The nitrates will. Those will be spectators. 2Cl minus plus 2Ag plus goes to AgCl. I'm sorry, I forgot to carry this 2 down here, and you should have a 2 right here. This is your net ionic equation. Good luck on your precipitation reactions homework.